Eighth graders, it's Mrs. Thompson. We are going to go into section 8.2 now. We're in section 2 of chapter 8. We've been talking about quadratic functions. We did 5 examples already, and we're ready to add and layer on more information on top of what we already know. Now our goal for this particular section, section 2, examples 1 through 5, we want to find the zeros of a quadratic function from its graph. We want to be able to find the axis of symmetry and the vertex of a parabola. So I'm going to teach you how to do that. Our focus today is to learn how to find the zero of a function. Now that probably sounds really weird. Like, what in the world is a zero of a function? Well, very simply, and I even made it more simple than your book did, it is where your parabola crosses the x-axis. It's your x-intercepts. You could have 1, you could have 2, you could have none at all. You could have a parabola that never crosses the x-axis. So that's what we're looking for. Now if you're wondering, why did they use the word zero? Why does zero of a function mean the x-intercept? Basically, where the zero comes from is if you plug in 0 for the y, what are your x's? And that is your x-intercept. Remember from when we did linear equations, if y is 0, that means you don't move on the y-axis, then wherever you move on the x is on the x-axis itself. That's your x-intercept. That's a little bit of the rationale behind it. So if you see the words, find the zero of the function, all they're asking you to find is what in the world are the x-intercepts, okay? They're really simple from a graph. As long as they cross a grid intersection, you'll be able to accurately identify where they're located. So let's start with letter A. I'm going to work in red just because I think it'll be a little easier on your eyes. I've graphed all the ones out of your book onto this page so you can see them. You should also have those in your notes. Hopefully I drew those. I probably did, knowing me. So what we're going to do in letter A, this is the equation of our graph, but they graphed it for us, and that's what we want to focus on. And where you want to focus is where does your parabola cross the x-axis? So I circled the first point on the left and the second point on the right. And those are your zeros of your function here. And so we want to identify those zeros. So the zeros of this particular function are -1 and +2. So you don't have to write necessarily the name of the point, -1, 0, and 2, 0. You could just identify it as -1 and 2. Okay, so this one had 2. Clearly crosses the x-axis at 2 positions. Okay, so that one has 2 x-intercepts. Let's look at letter B. Letter B is graphed for you. Here's the function, -2x squared plus 4x minus 2. And it's graphed, and it actually crosses the x-axis at 1 point. That is possible. Remember what I said at the beginning of the video. You could have no functions at all, no zeros at all, because your parabola doesn't cross the x-axis. You could have 1 where your x-intercept, or 0, is the same point as your vertex. That's possible. Or you could have 2 totally separate ones, independent from your vertex. So we have 1 in letter B, and so this particular 0 is located at +1. Okay, let's go to C. Does it cross the x-axis? Here's the x-axis down here. Do you see that your parabola doesn't even cross that x-axis? So there are no zeros in this function. Okay, so you just saw examples of all 3 possibilities. You could possibly have a parabola that doesn't cross the x-axis, therefore there are no x-intercepts. You could have a parabola whose vertex rests on the x-axis, and so that means it has 1, 0. Or you could have a parabola that crisscrosses the x-axis at 2 separate points, and so you identify what those are. Okay? Now on the next page, I'm going to leave these for extra credit. I'm going to give +1 for each. And I want you to identify the zero or zeros of these functions. If you have questions, write them down and let's talk about them in class tomorrow.